Hey there, hi there, ho there. Today I'm going to tell you about a new project I'm kicking off. So for a little while now, I've had in mind some kind of an experiment that I could put together here that would simply and practically compare tillage to no tillage as far as compaction is concerned. It's a constant argument between the die-hard no-tillers and the die-hard tillers as to whether or not tillage causes compaction in the soil. Now, everybody that farms a grain farm, every farmer in the United States of America knows that compaction is bad for crop production. The die-hard tillers claim that the tillage that they do alleviates compaction by tearing the soil up and lifting it and letting air into it and all the things that does. The die-hard no-tillers say no, ultimately the tillage creates compaction because it tears up the soil structure and rips it into finer chunks so it can pack in more tightly, and it kills off the soil biology, which needs all those channels and that pore space in the soil system. Now, the scientific data that I've been reading lately is tending to promote the idea that no-till actually alleviates compaction over the long term, especially if you combine it with cover crops, but that's not what this experiment is intended to prove. What I'm going to do is an experiment that will demonstrate whether or not tillage by itself compared to no tillage by itself, all other things being equal, causes compaction or does not cause compaction. Here's the way I've decided I'm going to do that. I'm going to pull a soil sample, a rather large chunk of soil, from the field tomorrow, which is December the 30th. December 30th in Darke County, Ohio. Today it got as high as 35 degrees. Tomorrow it's supposed to reach 30 degrees. A couple of days ago it was 60 degrees. The soil is a little bit frozen, but I think tomorrow at 30 degrees it won't be so frozen that I can't dig out a nice chunk of soil. And I would like for it to be a little bit frozen because that way when I dig it out with a shovel, I'm going to do this by hand, the ice crystals that will be in the pore space of that soil will kind of prevent me from creating some compaction simply by digging that soil out. But here's what I've been studying how I might do this for about 3 months now. And I finally figured out how I want to go about it. I went to the Dollar General store that's close to my house, and I bought these nifty containers. I bought 2 of them, and they were inexpensive enough. And I'm going to rip the lids off of these so that I've got this container. I'm going to poke some holes in the bottom of this so that it can drain out. I'm going to go dig out a slug of soil that will fill 2 of these to within an inch of the top. When I've dug that soil out, I'm going to get it all from the same spot. I'm not going to go to different places on the farm. I'm going to get a chunk of soil from the same spot on the farm. I'm going to pick one of our average soils that's around here so that it's the same soil going into both containers. I'm going to let it air dry until it's dry to the room humidity and the room temperature. Then I'm going to carve it up into 2 equal slugs that will just fit into this container and fill it to within an inch of the top. Now I'm going to leave an inch of free space up here for purposes of the experiment that I'll explain to you later, but during the experiment, I'm going to re-wet that soil, and I want some head space up here so when I simulate rainfall on this, anything that pools up on the top does not overflow. It has a chance to go down through the soil profile, because I'm not going to address runoff or infiltration. There's going to be some evidence of those things happen during this experiment, but that is not my focus. My focus is going to be purely this sample got tilled, that sample did not get tilled, and here's the way I'm going to do that. Once I've cut those soil samples into 2 equal portions and put them into this container, I'm going to simulate tillage on one of them and leave the other one alone. And then I'm going to re-wet it a couple of times. First, I'm going to simulate the fall tillage that we would normally have done when I was in the tillage system. Then I'm going to re-wet it a couple of times. Then I'm going to freeze them both. I'm going to wet them the same, then I'm going to freeze them both, and I'm actually going to take these containers, I'm going to put them in my deep freeze on my porch, and I'm going to leave them there for a little while until they are both completely frozen to simulate them going through the winter months. Then I'm going to pull them out, and I'm going to let them thaw and dry out again, and then I'm going to re-wet them a couple of times again, both equally, with the same amount of water. And then after that has happened, which will simulate the spring rainfall, I'm going to simulate on the tilled sample the spring tillage that I would have done and leave the other one alone. And once they've air dried again, I'm going to wet them 1 or 2 more times. After that process is complete, what we're going to find out is whether the volume of the 2 different soil samples is different. What I expect is going to happen, but this is just a hypothesis, and I'm going to have to live with the results of this just like everybody else is. What I expect is going to happen is that the one that I simulate the tillage on is going to compress or compact, and that 1-inch headroom that I left in here is going to sink, and it's going to wind up, the same amount of material is going to wind up in a lesser volume than the one that I don't disturb. Now, the premise that I'm promoting here is that if you have the same amount of soil material in a lesser space, it must be more compact, which means that the tillage caused compactions. The thing that is going to be left out, because I'm going to do this, what I have in mind is to take a knife and ram a knife down in there to simulate the tillage. So I'm not putting any wheel traffic on this. You know, we drive these tractors out across this farm that weigh 10 or 12 or 14,000 pounds, and that wheel pressure causes some compaction. That's not going to be a part of it. We have all kinds of other things that we do. I'm eliminating all that. The only difference between the 2 samples is going to be that I chopped this one up and I didn't chop that one up. And I'm going to be fair when I do this. I'm not going to run this thing through a grinder and pulverize it. I'm going to slice a knife down through it a couple of times and then clean up the top some to, as closely as I can see, simulate what would actually happen to it in the field. So that's the experiment that I'm starting tomorrow. I'm going to run some more videos on this to fill you in. So if you're interested in things like soil compaction and how tillage or no-till systems affect that, keep watching. If you like what I'm doing here, click the like button, click the subscribe button. This is going to be an ongoing project. My estimation is that it's going to take probably till the first part of March to complete this experiment. I don't know that for sure because I don't know how long the drying times will take each time I wet this and dry it again. I'm going to, as closely as I can, approximate the situations that these soils might see in the field, but in any case, the two samples are going to be treated exactly the same. I'm going to get them from the same place in the field. I'm going to dry them the same. I'm going to re-wet them the same. I'm going to freeze them the same. The only difference is one container of soil is going to get some tillage, the other one isn't. And when the experiment wraps up, we'll do the measurements and we'll see which one consumes more volume in the containers at that point in time. And that will answer the question on an experimental basis and on a common sense basis as to whether or not tillage causes or alleviates compaction. I hope you tune in to see this. I'm interested in seeing how it turns out.